page 130. This is section 5.2. So, listen up. What we're going to be doing is simplifying radicals. So, you have to understand what it means to have the simplest form of a radical in order to put it in simplest form. So, here's the first thing, is that no radicans. Radicans are the numbers under the radical. So no radicans have perfect nth powers. No radicans have perfect nth powers. So what do I mean by that? Well, that means if I had the square root of 8, 8 can be broken down into 4 times 2, and I can take the square root of 4. So therefore, this would not be in simplest form. A more advanced example would be like if I asked you the cube root of 2,000. Well, 2,000 is 2 times 1,000, and there's a cube root of 1,000. So that form right there is not simplified. I would have to take this down to 10 cube root of 2, and I'd have to take this down to 2 radical 2 to have it in simplest form. So that's the first rule. The second rule is no radicans contain fractions. So if I have a fraction, I need to figure out a way to get rid of the fraction. And the other thing is, no radicals appear in the denominator. If they do appear in the denominator, then I'm going to have to use multiplying by the conjugate if I have 2 values, or I'm going to have to just rationalize the denominator. We'll talk about that later. Conjugate, all that means is if I have something like 1 plus radical 3, what's the conjugate? Yeah, you just change that middle sign. Like radicals, when we have like radicals, we have to have the same index and the same radicand. When I'm talking about the index, that's the same thing as the root. So like if I have the cube root of 5 and the cube root of 5, I'll put a 6 in front of this one. So I have cube root of 5 and 6 cube root of 5. These would be like radicals because they have the same index of 3 and they have the same radicand of 5. All right? Okay, properties of rational exponents. Now you've learned all of these properties in Algebra 1, but you may not have done them with rational exponents. Rational means fractional. So you've done this when you've just had whole number exponents, but probably not when you've had the fractions. If we have like bases and we're multiplying, we add the exponents. Okay? The reason we do that is this. Let's say I've got 4 cubed times 4 squared. Well, that's going to mean 4 times 4 times 4 times 4 times 4. Can you see how in this situation, what does this end up being? 4 to the 5th. So can you see how the base stays the same? So this answer, the base stays the same, but we add the exponents. And we're going to be doing that, though, when we have fractions. So like they're showing you, 5 to the 1/2 times 5 to the 3/2, the base stays the same, you add the exponents. If I have a power to a power, or power of a power. Here they're showing us, if I have 3 to the 5/2 to the 2nd, I multiply these. Now the reason why using non-rational exponents is suppose I have this case. Well, this would mean 4 to the 3rd times 4 to the 3rd. That's going to be 4 to the what power? 6. Okay, so we can see how those rules work. Here's one that you may have forgotten about, and it's going to come up quite a bit. If I have a to the m and b to the m, I can multiply a times b. What we're talking about here is, let's say that I have the square root, or let's make it more difficult. Let's say I've got the fourth root of 2 times the fourth root of 4. Well, because they're both fourth roots, that would be the fourth root of 8. That I'm sure you know about. But when it's written as 2 to the 1/4 times 4 to the 1/4, it seems like people forget this. Our exponents are the same, so I can multiply the bases and say this is 8 to the 1/4. Can you see how that works for both of them? It's the same thing. If we have a negative exponent, it's going to go to the denominator. We talked about that already. Anything to the 0 power is 1. If I have something that's getting divided in their like bases, then I can subtract the exponents and keep the base. They show us that here. Base stays the same, subtract the exponents. And then if we have a power of a quotient, I can just do, like in this situation, it's just going to be 27 to the 1/3, which is 3, 64 to the 1/3, which is 4. All right, flip over on the back, or page 131 rather. This is our product property, and I actually already talked about this one, but just saying that if I have those like radicals, I can just multiply what's under there and simplify. Same thing holds true for division. All right, let me show you one, though, that people sometimes struggle with. So let's say that we've got 7 to the 2/3 times 9 to the 2/3. Well, another name for that is just going to be 63 to the 2/3. Okay? You see what I'm saying there? The exponents are the same. We can multiply the bases, and those would be equivalent. And let's say you're thinking, you're taking ACTs or something, and you're like, I do not think that seems right. Well, just do it like this. Just watch. 7 to the 2/3 times 9 to the 2/3. If I can type it in right. Shoot. 7 to the 2/3 times 9 to the 2/3. Oh my goodness, forget it. Trust me on it, it's right. All right, let's go down here. Okay, so we're going to use the properties of rational exponents to simplify. So looking at this one, guys, I have a couple of ways I can do this. Here's one way. I can say I've got 2 to the 3rd to the negative 1/3. So because I have a power to a power, what can I do with the exponents? Multiply, and I would get 2 to the negative 1 times 3 to the negative 1, right? So now I'm going to have 1/2 times 1/3, which is 1/6. See how I did that? Now here's the other way I could have done it. Both of these have like exponents, so I could have just multiplied these two together, and I could have thought of this as 6 to the 3rd, and then to the negative 1/3. Well, now what would it be if I have a power to a power? 6 to the what? Negative first, which would still be 1/6. So you can do these a lot of different ways, but you have to make sure that you follow the rules of exponents. What do we do if we're dividing and we have like bases? What am I supposed to do with the exponents? Subtract them. What's the exponent here? 1. So I'm going to have to subtract these exponents. So it's going to be 10 to the 1 minus negative 4/5. What's 1 minus negative 4/5? 1 4/5, which would be 10 to the what? 9/5. Everybody see why that would be 10 to the 9/5? Now, here's the thing on your homework. At the beginning, they're going to let you leave it like this. This is called rational exponent form. But they also later on are going to ask you to write this in radical form. So what does this mean in radical form? What's the root? Remember what we talked about when we have a rational exponent? What's the root? 5. So it's going to be the 5th root of 10 to what power? To the 9th. So think about this. If I have 10 9s, I really don't want to write them all out, so don't make me. If I have 9 10s rather, not 10 9s, 9 10s. If I have 9 10s under there, I have to have 5 alike to take it out. So would I have 5 that are alike? Yeah. So I could take 1 10 out. How many would be left inside of there? 4 10s would be left inside, right? So I would have 10 to the 4th on the inside. So what is 10 to the 4th? A 1 with 10 zeros, or a 1 with 4 zeros is going to be what? 10,000. This would be the answer in radical form. Like I said, at the beginning of your homework, they're going to say to put it into simplest form with rational exponents. So it's going to look like that. But if they had asked you to do it in radical form, which they do later, then you would write it like that. Okay? All right, what about this one? What can I do to make this easier? If this is to the 5th and this is to the 5th, what can I do with those two numbers? Divide them, right? So 52 divided by 4, what is that? 13. So then I'd have 13 to the 5th, now to the 1/6. And what do I do if I have a power to a power? What do we do? Multiply, so it's 13 to the 5/6. So this would be your answer at the beginning set of the homework. At the end part, they would ask you to write it in radical form, so you'd write it like that. You see the difference? The 6th root of 13 to the 5th. All right, look at this one now. Do we have like exponents? No, so I need to just do something else then. I can't do anything with that. That's just 3 to the 1/3. But this one I can evaluate. Remember, this is my root. So what's the cube root of 27 squared? So I have 9 on the top. And then what's the cube root of 8 to the 4th? 16. And so I can write this as 9 times 3 to the 1/3 over 16. That's the way they'd write it at the beginning. Can anybody think of how you would write that in radical form? It would be 9, and then what's the root here? So it would be the cube root of 3 over 16. That would be later once you start writing it in radical form. So we have two forms, rational exponent, radicals. Okay, number 5, find the simplified expressions for the perimeter and the area. How do we find perimeter? What's that mean? Distance all the way around, right? So this is a square, so this is 10x to the 1/4. This is 10x to the 1/4. This is 10x to the 1/4. So how am I going to find the perimeter? What do I have to do? Add them up. What are we going to get if we add them up? Good. That would be using rational exponents. Can anybody write it in radical form? What would it be? Zane? Yeah? Well, the 40 would be on the outside, actually. Yep. 40, 4th root of x is the way that's said. The 40 is not to the 4th root, only the x is. So you could either put it rational exponent, radical. And then area. What do we do to find area? Okay, I can either square this or I can say this times this, right? So what if I squared it? 10x to the 1/4 squared. Well, I'd have to square the 10 and get 100. Then I'd have an x, and then what do I do with 1/4 and 2? 1/2. So I could have that. What if I had done it this way? 10x to the 1/2 or 1/4 times 10x to the 1/4. If I'd done base times height, would I have gotten the same answer? What's the rule? I get 100. What do I do if I have x's? What do I do with the exponents? Add them. What's 1/4 plus 1/4? 2/4, which is, I get the same answer, don't I? Do you realize that this could also be written that way? It'd be the same thing? Okay. All right, on to the back. Okay, so now it says to use the properties of radicals. So this will be in that part where they want it in simplest radical form. So I've already kind of shown you how to do this a little bit. So we've got the 6th root of 25, and I can't do the 6th root of 25. So I've just got to think of it as the 6th root of 5 squared. I can't do anything with that. And then this would be the 6th root, 625. Anybody know what that would what multiplies to be 625? It's actually 25 times 25. So what's that going to be then? 5 to the 4th. So now look, I've got like roots. So this is going to be the 6th root of 5 to what power? 6. So if I had the 6th root of 5 to the 6th, what's it going to be? Just 5. Okay, on these, if I have like radicals, to simplify, I'm not supposed to have fractions, but instead of rationalizing the denominator, I should think, can I just divide these? Just 343 divided by 7, what is that? 34 divided by 7 would be
49.
It's 49. So now I still have the radical, guys. So I have radical 49. Okay, because all I did was divide. I haven't taken any square roots yet. And so this answer is just going to be 7. All right, on the next one, when we are doing this kind of problem, I either divide these two or I divide these two. People always think, well, if I divide this one, don't I have to divide that one? No, think of an easier problem. Look at this, guys. If I asked you 4 times 2 divided by 2, what's the answer to that? 4. Would you divide 4 by 2 and 2 by 2 to get the answer? No, just one or the other, right? Same thing here. I don't divide both of them by 2, even though I can't divide that by 2 evenly. I just divide this one by 2. So I'm going to have the cube root of 25 times the cube root of 5. Well, now I've got the cube root of 5 squared times the cube root of 5 to the 1st. So that's the cube root of 5 to the 3rd. So what's our answer? Just 5. You also could have just multiplied these. 25 times 5 is 125. Cube root of 125 is 5. Lots of ways to do these. All right. Let's look at this one. I'm trying to do the 7th root of 384. I don't know what that is. I'm sure no one knows right off what that is. Oh, I was like, what? You do? All right, so probably not. Here's what I would like to do, though, is think of my divisibility rules. I know this can be divided by 2, right? If I add up these digits, 3 plus 8 is 11 plus 4 is 15. That tells me it can also be divided by 3. Go ahead. It can be divided by 6 then, can it? Is the answer 6?
Well, no, I don't think it's 7. Or I was thinking it was
Okay, well, let's keep going with it. I know it can be divided by 6, so I'm going to put it 6 times. 38 divided by 6 is 6. With 2 left over, 6 goes into 24 4 times. So it's 6 times 64. I'm trying to get you to do this without a calculator, okay? So I'm trying to show you divisibility rules. So we've got 6 is now going to be 3 times 2. 64, what's 64 going to be? 8 times 8, which, what is 8 times 8 going to be? 8 is what? 2 to the, so I have 2 to the 3rd, and then this 8's 2 to the 3rd. So do you see what I've got now? I've got 2, 2 to the 3rd, and 2 to the 3rd. So what is this then? 2 to the 7th. And so what's the 7th root of 2 to the 7th? Just 2. So I'm going to end up with just 2 7th root of 3. All right? You guys with me on that? If not, raise your hand and ask, because I want you to understand that. Again, this is 2 times 2 times 2 times 2 times 2 times 2 times 2. So I'd have 7 2's under there. If I'm taking the 7th root of 7 2's, then the 2 comes out, the 3 stays in. Okay, number 10. We are going to break this apart. This is the cube root of 5 over the cube root of 9. I'm not allowed to have radicals in the denominator, and I can't divide. Does anybody know what I should multiply by then? What? Would radical 9 do it though? Because then I'm going to get the cube root of 81. Is there a cube root of 81? So what do I want to do? Cube root of 27 is a cube root, isn't it? So what am I going to multiply by then to get 27? So I'm going to have to multiply by the cube root of 3 on top and bottom. So now I'm going to have the cube root of 15 over the cube root of 27. I can't do anything with that, but what's the cube root of 27? 3. And guys, think of it this way. 9 is 3 times 3. I want to have 3 3s, right, to be able to take it out, so I needed one more 3. See what I'm saying? Lots of different ways of thinking of that. All right, number 12. You've done this before. What do we multiply by? The not just radical 6, but the conjugate. You always want to multiply by the conjugate in this case. So what's the conjugate? So we have to multiply by that on the top and the bottom. So when I multiply by that on the top, I'm going to get radical 2 minus radical 12. Down here I get 1. My outers are negative radical 6. My inners are positive radical 6. My last is going to be minus radical 36. So now I want to simplify this. I have radical 2 minus, this is 4 times 3. So what's that going to be? 2 radical 3 is right. On the bottom, I've got negative radical 6 plus radical 6. And then the square root of 36 is just 6. So I have minus 5. Negative 5. So we can leave it like this. But I also want you to know it could be written like this. See if you would understand why. You see why those are equivalent? I've got this that's getting divided by negative 5 and this that's getting divided by negative 5. See, this is subtraction. It's not multiplication. So they're both getting divided. If it had been multiplication, only one of them would be getting divided. But that's our final answer. Okay, guys, 2 more. You can see how difficult this is going to get, too. This is one of our harder sections that we do. Okay, so to add or subtract, we have to have like radicans. Do we have like radicans here? Do we have like indices? Yep. So what's the answer then? Just what? 38 cube root of 5. On this one, I have to simplify first. So I have 2, and then this is 1250. So let's think of numbers that multiply to be 1250. 10 times 125. How many do I have to have alike to be able to take it out if I have to the 1/4? I have to get something to the 4th power, right? Okay, so watch. This is 2. 10 is 5 times 2. 125 is 5 to the what? Third. So I'm just working with this part. So really what I've got is 2 times 5 to the 4th to the 1/4. You see what I've got here? I've got 5 to the 4th to the 1/4. So then what can I do with this? This right here can be taken out, can it? Because I'm going to get 5 to the 4/4. Okay, so I'm going to take out the 5, so I'm going to have a 2. The 5 comes out. Can the 2 come out? No. So it's just going to be still there as 2 to the 1/4. Okay, what about 32 now? 32 is what? 16 times 2. So I'm going to have, for the 32, I'm going to have 5 times, 32 is 2 to what power then? 2 to the, count it out. 2 times 2 is 4, times 2 is 8, times 2 is, what is it? 2 to the 5th. So I'm going to have 2 to the 5th there. So how many So I'm going to have 1, 2 that's going to come out. So I have 1, 2 that comes out, and then I'm going to have 1, 2 that stays in. 1, 2 is going to still be to the 1/4. You guys follow me on this one? Kind of tough. So now I have 2 times 5 is going to be 10. And I can write this as the 4th root of 2 if I want. And then this is 10. And then this is the 4th root of 2. All that work, and what's the answer? 0. All that work to get 0. Okay? So this is a tough section, and like I said, we're actually going to spend 3 days on this because there's so much to it. Okay? So day 1, your assignment's up there. It's also on your assignment sheet that I gave you.